Have you guys ever seen an indeterminate form inside of an indeterminate form? If not, I make this for you guys. Let's take a look of the limit as x goes to infinity of this expression minus that expression and then raised to the x power. As always, we should plug in this into all the x to see what we get, right? So let's do that. You see, for this right here, we know square root is an increasing function, and inside here we have positive x squared, and this is quadratic, so that's also increasing. So that means this right here has to go to positive infinity, right? So the first part is going to give us infinity, and then we subtract the second one right here, which is a similar reason. We also have infinity here. Infinity minus infinity, this is an indeterminate form already, but we're not done yet because we put a parenthesis around this. The x is also going toward infinity, right? Oh my god, this is infinity minus infinity and then raised to infinity power. You know, there's actually a bad number, right? Because for example, if infinity minus infinity, if this happens to be 2, and then you raise that to the infinity's power, this goes to infinity. We can draw a conclusion right here, right? And if this inside turns out to be, let's say, a fraction such as 1/3, a fraction less than 1, and then you raise that to the infinity power, this, we can also draw a conclusion. This is going toward 0. That's good. However, what if we have infinity minus infinity inside turns out to be the bad number, which is 1? If we have 1 and then raised to the infinity's power, in fact, I have no idea what this is going to be. This is an indeterminate form. And by the way, whenever we are doing limits and we write down 1, this is not a solid 1, okay? This means, you can imagine we have 1.000001. It's just a number that's really close to 1, just as 1.0001 or maybe 0.99999, all right? And this is how we usually write it. We don't put down 1.00001 to the infinity's power. This is the form of the limits, all right? But anyway, you can kind of know what this is going to turn out to be, right? Otherwise, how is this video going to be fun, right? But I'm going to erase it, and I will have to first check the limit of just the inside, all right? So let's do that right here. Let me just put this down right here. I will check the limit as x goes to infinity of just the inside. Namely, we have the square root of x squared plus 2x plus 3 minus square root of x squared plus 3, right? Okay, this is indeterminate, but this is not good at all in the sense that I cannot use L'Hopital's rule, right? Because it's infinity minus infinity, right? What can we do now? Don't forget, we have to make our algebra teacher proud, right? Whenever we are talking about square roots, we should think about its conjugate. So in this case, why don't we just multiply the top and bottom by its conjugate to see what we get? So I'm going to multiply the top by the square root of x squared plus 2x plus 3, and then I'll change the minus to a plus, and then the other term, which is the square root of x squared plus 3, and then we'll divide it by this, of course. Namely, square root of x squared plus 2x plus 3, and then plus square root of x squared plus 3. Okay, so let's see what we get, right? This is still, of course, the limit as x goes to infinity. And we are going to do a lot of computation in our head, right? Otherwise, I can never finish this question, and also this word wouldn't fit. Anyway, this is the denominator. I'll just write it down. X squared plus 2x plus 3 plus square root of x squared plus 3. On the top, this is in the form of a minus b times a plus b, and you know the result is going to be a squared minus b squared. And when x is going toward infinity, this is positive infinity. Well, you see, the coefficient of the x squared is positive 1. So that means when you have this, you end up with a positive version of the inside, right? Because technically, when you have the square root of x squared whatsoever, you do the absolute value of this, but x is going to a positive infinity. Therefore, we don't need an absolute value. This times this, it's a squared, it's just the inside now. So this is x squared plus 2x plus 3, but we'll subtract this thing squared, which is x squared plus 3, right? So be sure you put parentheses, and now cancel this out because x squared minus x squared, and also 3 minus 3, right? So that's good. And on the top, we have a 2x left. And this is now the limit as x goes to infinity. 2x on top over this, right? So you can watch my other video. Well, the deal is that in this case, you can show work in the sense you can divide everything by x to the first power, but as I told you, I will try to skip some steps. The shorthand way to do it is I will circle the top, which is the only term, 2x, and on the denominator, I will just pick up the part that matters. From here, only this part matters, square root of x squared. Likewise for this right here, only this matters, right? And again, this right here, square root of x squared is just x. Square root of x squared is just going to be x when x is going to work past the infinity. We don't need the absolute value, all right? X plus x is 2x. So in another word, this is just the limit as x goes to infinity. On the top, we have this 2x. On the bottom is this times this plus that, which is 2x. So this cancel, this cancel. At the end, we get 1 for this, right? This right here is approaching to 1 inside, but then we raise that to the infinity. So I don't know what this is going to be. So we have to do more work, right? Oh well, let's see, what can we do? When we have a function raised to a function in the limit situation or in the derivative situation, we can say this is equal to L and then do the ln both sides. Or you can also write the base as e to the ln of whatever this is, right? This is a huge expression. So let me just say this is L, and I'll make this equal to that. And I'll just do the ln both sides, right? So I'll do natural log of L on the left-hand side. And we know the natural log of the limit, it's the limit of the natural log because natural log is the continuous function. So I will just put the ln inside like this, okay? So now on the left-hand side, we have the natural log of L, and this is going to be the limit as x goes toward past the infinity. Let me just write down the natural log of this part first, okay? So we will have ln of the square root of x squared plus 2x plus 3 minus square root of x squared plus 3, right? Well, I had this x earlier in the exponent, but by one of the ln property, I can bring that x to the front, right? I can do this. Well, if you plug in infinity into this x and that part, we will end up with infinity times. And when we plug in infinity into this, you know this right here is going to give you 1 for the limit. So ln 1 is going to be 0. Check this out. We have infinity times 0. And we are going to see a lot of indeterminate forms, right? We have dealt with infinity minus infinity already. And then we also encounter 1 to the infinity's power. And now we also have infinity times 0, right? Anyway, once we have this situation, we should bring one of the factor down so that we can produce either 0 over 0 or infinity over infinity situation, all right? And then we can use L'Hopital's rule. Well, if you want to bring this down, I'll leave that to you. I will bring the x down, all right? So let me just erase the x, and then I'll bring that down, which becomes 1 over x. And that's what I mean by bring the x down. So I will have the 1 over x in the denominator. And now we don't have infinity times 0 anymore. We will see when we plug in infinity on the top, this is going to give us 0 and 1, right? And then when we plug in infinity into here, this is 1 over infinity, which is 0. Now we can use L'Hopital's rule because that's a 0 over 0 situation. And let me indicate this for you guys. This is 0 over 0. Use L'Hopital's rule. And we still have ln L, so keep that in mind. But let's focus on this. This is still the limit as x goes to infinity. And now do the L'Hopital's rule by differentiate the top and also differentiate the bottom. Okay, let's see what kind of things are we going to end up with. It's pretty crazy, I know. Anyway, the derivative of ln of something is going to be 1 over the inside, which is the square root of x squared plus 2x plus 3, and then minus square root of x squared plus 3, right? And we multiply by the derivative of the inside because of the chain rule. So I will have to multiply by the derivative of these two things. Let's open the parentheses. Derivative of the first square root part right here, it's going to be 1 over 2 times the square root of the inside, which is x squared plus 2x plus 3. And we have to do the chain rule again. So we multiply by the derivative of this, which is going to give us 2x plus 2, right? And now we subtract the derivative of that, which is 1 over 2 square root of x squared plus 3 for now. And then do the chain rule one more time right here. Multiply by 2x like that. And we close it, okay? And that's the derivative on the top. The derivative of 1 over x, which is on the bottom right here, is just simply negative 1 over x squared, all right? Okay, now what? Well, here is the technical part. When we are taking a limit of a product of the first thing, second thing, and technically this is like 1 over whatever that is, right? It's a product of the limits if each part has a limit, all right? So in fact, we can actually draw a conclusion for the first part. Why? Because if you just focus on the first part, we can just take the limit of 1 over the limit of the bottom. And the limit of the bottom, this right here, we saw it. It was approaching to 1, right? Therefore, I will tell you, this right here is going to be toward 1. And I'm just going to circle this whole part here. This right here is approaching to 1. So I will just draw the arrow this way, 1, right? Once again, it's a limit on the top, which is 1, and then the limit on the bottom of this part, which is the one in blue. 1 over 1, it's approaching to 1 for that part. So by that, we can ignore this expression, because 1 times the rest is just the rest. Okay, so now we just have to focus on this guy, all right? So I will just go ahead and continue with my work. I will have the one limit, just put on the 1 to honor this limit right here. And then we have the limit when x approach to infinity, this part. And let's see what we're going to do. We have negative 1 over x squared on the bottom like this. Let's bring upward. How's that? So it's going to be negative x squared, right? And then we are going to multiply by this part now, which is this minus that. First of all, we have a 2. We can cancel things out. So let's cancel this 2 with these two 2's. And don't forget, it's going to be a 1, right? And then this 2 and that 2 can be also canceled out as well. We have a fraction minus a fraction inside. Why don't we just combine the fractions, right? So let's do that. Let's put on a big fraction bar. You know the common denominator is going to be this times that. So let's just write it down. X squared plus 2x plus 3 times that square root of x squared plus 3. And you know the numerator is going to be this times that. So let's put that down as well. Parentheses, this is x plus 1, right? X plus 1 times this square root of x squared plus 3 minus, this is x times that, which is square root of x squared plus 2x plus 3, all right? Like this. So far, so good. And imagine if I put this question down on my calculus 2 final exam. I don't know if I will do it or not, but anyway. So this is what we have. Okay, let's see what do we have next. Let me just write down the limit. 1 times this doesn't matter, so limit as x goes to infinity. What shall we do next? Well, once again, we'll pair things up to make our life easier, right? This part looks suspicious because this reminds me of what we did earlier, right? So why don't we just pair things up like this right here, okay? Well, as x goes to infinity, of course, this is negative x squared that goes to negative infinity. But how about this part? Same idea right here, right? So this is just like, I just need to come up with an answer real quick. So I'm not going to show too much work in some sense, right? So I will just circle it. We just care about this part. This is going to be toward x. Likewise, this is also going to be toward x, right? Now, x squared on the top, and we have x on the bottom. So we can cancel them out, right? So in another word, you can cancel this one with that one. The things that pair up, we just have a negative 1, all right? So altogether, we have a negative 1 factor. And now we have this guy. So what do we do? Square root, square root. Let's try the conjugate method one more time, all right? I will open parentheses first. Let me write this down. So we have the x plus 1 square root of x squared plus 3 minus x square root of x squared plus 2x plus 3. And as I said, I will multiply the top and bottom by its conjugate. So let's do that in blue. I will multiply this x plus 1 square root of x squared plus 3 plus, right? And then we have the x square root of x squared plus 2x plus 3. Okay, close this. And then we have to divide it by that, which is this. X plus 1 times the square root of x squared plus 3 plus x square root of x squared plus 2x plus 3. And I will close this part in black. All right. The answer is going to be negative of this. So now let's investigate what this is going to be, all right? So let's write this down. Again, this is going to be negative, and let's write down the limit as x goes to infinity, all right? So on the bottom, we have that. On the top, we have the a minus b times a plus b form, right? All right, so let's just multiply out the top. And once again, everything will become positive when x is going to work past infinity, right? So we don't need any absolute value whatsoever. So I will just square the first term. I will end up with x plus 1 square, and then this thing square is just a parentheses, x squared plus 3, right? And then I'll minus the second term square, which is going to be x square, and then this thing square, which is going to be just a parentheses, x squared plus 2x plus 3, like this, okay? And this right here stays in the denominator. Let me just write it down, x plus 1 square root of x squared plus 3 plus x square root of x squared plus 3, plus 2x plus 3. All right? And yes, I came up with this question myself, just to let you guys know. And anyway, so now here is the hardcore part. We are just going to do a lot of algebra, because I had to pretty much do the similar things right here. I have to pick out the dominating part, but I need to see if there's anything that will cancel out first, right? I know on the bottom, the things that will be dominating is the x times the square root of x squared, right? So it's this right here. So it's like that. So this is going to be x times another x. That's going to be x squared, all right? And likewise, we have x right here times square root of x squared. So this is going to be x times x. So that's x squared plus x squared on the denominator that we care, right? So it's similar to this. Now on the top, I just had to work this out. So let's see. This is x plus 1 squared, and then times that. I know we have to just do the work, so let's do the work right here perhaps. And I will just put it down right here. I think I should have enough space to work this out. Yes, I will do this one in red, right? So here we go to multiply this out. X plus 1 squared, we know this is going to be x squared plus 2x plus 1 times the x squared plus 3, right? So you just distribute this backwards. Actually, I can just do it right here now. Because x squared times that, it's x to the fourth power. I can handle that. Likewise, this times that is plus 2x to the third power, right? So I can handle that plus 2x to the third power. And then I'm doing this backwards. It's easier this way. So plus 2. So plus x squared. So this times this is just x squared. The 2 is at the wrong place. And why am I using my finger? I don't know. I'm just going to do this times that plus 3x squared, and then 3 times that plus 6x, and then this times that is plus 3, all right? So that's the expansion of this. And now multiply this out. I'll do this in blue. So this times this is negative x squared times x squared, which is x to the fourth power. This times that is negative 2x to the third power. Seriously, I should not use my finger to erase this, but anyway. This times that is negative 2x to the third power. This times that is negative 3x squared, right? Okay, I'll do the cancellation in black. X to the fourth power cancel each other out. And 2x to the third power have a negative version, so they cancel out. So far, so good. And look at this is 3x squared. Cancel this out. Cancel that out. Whew! I have x squared plus 6x plus 3 on the top, and I think that's pretty much the deal, right? So in fact, I didn't even need a lot of space right here. That's what we have. So what are we getting right here? On the top, what do we care? We just care about this x squared, right? Because that's the dominating part. And we have x squared plus x squared, right? So don't forget we still have the negative right here though. So this is negative times the limit of x approaching to infinity. On the top is x squared. On the bottom is x squared plus x squared. So that's 2x squared. Oh, this is going to be negative 1/2. But is this the answer? No, it's not, because don't forget we are doing ln L, right? So at the end, right here, draw the same box again. We know ln L is equal to negative 1/2. Of course, do E, both sides cancel this out. L is equal to that, but L, we know it's the original question. So let me just write it down, original version. So to be legitimate, you know, the limit as x goes to infinity of that. And ladies and gentlemen, seriously, this is an indeterminate form inside of an indeterminate form, all right? For your Christmas gift or things like that. And maybe you need to make sure that your Calculus 2 teacher doesn't see this. Otherwise, I don't know. Anyway, at the end, this is e to the negative 1/2. 1 over e to the positive 1/2. But let's be fancy. Let's write this down as 1 over square root of e. How is this? And this is the final result I want to present to you guys. All right? So this is the answer. 1 over square root of e. Right? And hopefully you guys like this right here. That's it.